I was pointing at a forever card. For anybody just joining us, I was pointing at your forever card, which already has the word acceleration, and we were reviewing what he is. In words, he's the rate of change of who? He's the rate of change of who? Velocity. Why? Because doesn't rate of change mean a derivative, right? He's v prime. How would we describe him in, or with respect to, that's a snazzy math way, position? He's the rate of change of the rate of change of position. Because who is he?
He's the
Second derivative. Oh, that's right. We saw this at the end of class yesterday, that there are higher derivatives than the first. Our goal is to finish motion, talking about acceleration for just a second, then popping over to grade R, section 2.3 homework. So have a color pen ready and your homework spirals open. I'll go ahead and open up over here as well, so that we have the answer key. But after we finish this motion dealio, we'll grade our homework quick, see how you guys did on product and quotient. We'll see when it gets hard, where it gets hard, why it gets hard. And then we'll move on to introduce section 2.4. Hey guys, section 2.4. When's that homework due? Look at the backboard real fast just so we're all staying. Nice. So we have a few sections. Hey, wait, we have a few days on 2.4. What might that mean? Small? It's full. It's important. It's crucial, and it's kind of tricky hard. Not hard as in taking a lot of time, hard as in concept-y difficult. I was asking BC kids as far as how to teach it, because there are multiple ways, and I showed them my new way. And some said, yes, it's so much easier, and some said it's just going to screw them up. And I'm like, great, okay. So I'm still kind of debating.
No helping.
Yeah, they only half helps. But anyway, I think the biggest concern wasn't so much it was going to screw you up, but more that it was going to slow you down. And on an AP test, slowing down is hard. So I'm kind of debating as to what's better. But anyway, before we get to section 2.4, it's coming. Homework's not due until Friday, so you can kind of take a deep breath. There isn't a lot of deadlines this week. There aren't a lot of deadlines this week. We have a forever quiz next week, a test next week, end of next weekish, maybe middle, because 2.4 I think is the last section for the chapter 2A test. Just 2.1 through 2.4 think derivative rules. Oh wait, wasn't 2.1 the definition of derivative, the limits of difference quotients? A little bit of limits stuff, but then all the basic rules. But guys, motion's going to be on the test, so hold on. How many of you guys took a second derivative? Oh, we didn't? We were amazing? We knew only one derivative? Why only one derivative?
Because we're not doing position, we're doing...
We don't have position, velocity. We have velocity. Good. That's one of the most important things when you're reading problems is what were you given, right? And so I'm going to go ahead and say acceleration is equal to d. Why am I writing dt? It's not enough to t. Otherwise, we're good. Yeah? Okay, and I'm going to go ahead and write my 100t all over 2t plus 15. I'm going to get my red pen because there's no rewriting. That will help. And why am I doing that? Quotient rule. I'm going to go ahead and do bottom, which is just rewriting, right? D top, which was 100. Quotient rule says what goes next? Minus subtraction. Top? D bottom? Why not 15? Derivative of any constant is all over bottom squared. Careful.
That's not squared.
Okay. It's going to prove a point too. There's a mathematical algebraic point. If that was the case, you would have squared both the t and the 100, right?
Okay.
I guess my mathematical point doesn't work. What should we do next? Distribute what? Am I simplifying, multiplying the top or the bottom or both?
The top.
well because I want him factored. Remember all of our limit work? We want to keep that denominator as simple as possible. Maybe something will reduce. Now, we could be super snazzy, and I'm going to get my green pen. This is called the green pen trick. In that some of you get overwhelmed and you don't realize this is kind of like a big old binomial. It's one term minus another term. I mean, it's not technically a binomial. There's pluses and minuses, but we can think about it as one minus another. You can always ask yourself, is there something in common?
Yes.
And if there is something in common, not two. If there is something in common, if we pull it out, our life might get easier. I see 100, but I see that as the only thing in common. Do you guys see why? There is a 2. There is a 2, but isn't this trapped in an addition? Can I pull that 2 out to make it in common to pull out? No. But I could have just distributed and made 200t and then 1500 and then 200t and then factored. But does anybody see why? And this one is a very small example. It's not 10 easier. Huh?
Did you get rid of the 200t?
Yeah.
200t minus 200t is 0. I just made it.
Okay, you guys are distributing. I'm not trying to prove that you can distribute. I'm trying to prove that you can pull out something in common and make the number small. Does that make sense? So what is going to be left when you pull out the, I'm just saying you can't pull out the 2. And you can't pull out a t, because there are a few of you that would have been like, yay, let's pull out the 2t, but there's a plus. What's left? The 100's gone, right?
Yeah.
The 100's gone. I have 2t plus 15 minus 2t, which the 2t's are going to reduce. You're totally right. But do you see how I kind of have smaller numbers than I would have otherwise? Because I pulled that 100 out. And once again, this is a silly example. Yes, you could have done 200 minus 200. It would have canceled out just like the 2t minus 2t did. 15 times 100 is 1500, or it's 100 times 15. And no, there's nothing that I can actually simplify. So it didn't actually help tons as far as getting us towards the answer. I'm just starting to introduce you guys to what's called the green pen trick. That's just me. That's not like calculus community at large. When we go looking for, is there anything in common to make my life easier later, as far as either easier expressions and or easier numbers? 2t plus 15, there is absolutely nothing you can do to simplify. But wait, what were they actually asking for?
On the acceleration of time seconds.
So what do I do once I have my acceleration function?
Plug in.
Plug it in, plug it in. We need a of 5, and a of 10, and a of, was it 15?
20.
20. So 5 times 20? You ready for some Six the Madness? If this was a long answer, you would do 2 times 5 plus 15 squared, and you would say feet per second squared, and say, haha, I'm done. And the long answer, oh yeah. So if you know multiplying, adding, squaring, dividing, you don't do so hot at it. And I'm not saying you can never do it well. I'm just saying you don't always do it perfectly. So why run the risk? Once again, if this was a long answer, if it's multiple choice, do you have a choice? Nope, you gotta simplify and make it match, right? So then, what's gonna change? Not much. Except this time all we're doing is plugging in 100.
10.
Struggle. I was doing the squaring and I don't know why. I still have coffee on my desk. Look at that. And then this last one you're going to do 1500 all over plugging in 20. Now, guys, if you were checking with the odds in the back of the book, wouldn't you have to make sure? Well, make sure it matches. Wouldn't you have to simplify? Yes. But just be aware. If it's a long answer, we just stop there and say, done. What do you guys notice about the units for acceleration and how they differ from velocity? Feet per second squared, it'd be like miles per hour squared. Miles per hour is a velocity unit you're more used to. Think of it this way. If acceleration is dv dt, does that make sense? dy dx, v prime of t, dv dt. Wouldn't it be units of velocity over units of time? Does that make sense? Units of velocity over units of time. Or if you think about it, every time we take a derivative, v of t was ds dt, which is units of position over units of time. And then position is just units of distance. Well, right? Every time we take a derivative, it's going to be per another second, unless they start giving you something like hours or minutes. Then we might have to do some building of bridges to get rid of what we don't want. Thank you, Mrs. Leon. Dimensional analysis, but for right now, acceleration is position over time squared, almost always. Position over time squared, almost always, because we need velocity units over time units. With that, kiddos, we did that higher derivative thing yesterday. Why did I keep taking derivatives on this page? Because I can? No, because I should, because I was told to, right? I didn't just keep taking derivatives. Now, every time I cover this section, there's somebody who, anytime they take a derivative, they're like, I'm supposed to keep going, and they go all the way to 0. And I'm like, what did you just do? Why are you doing that? You only take higher derivatives when they tell you to, right? You only take higher derivatives when they tell you to. But the question is, can we take more than one derivative? Can we? Can we? Yes. You can keep taking derivatives until it turns either DNE, non-existing, or trivial. We go until, or we can go until it turns trivial or it turns non-existent. Remember, differentiability, just a quick little note that I put in period 6 and I didn't for you guys. That's as long as the derivative exists. As long as the derivative exists. In non-trivial, basically it's non-zero. Let's do non-repeating. If you start getting the same derivative over and over and over again, you're probably done. AKA, usually it's 0. The next derivative is 0, the next derivative is 0, the next derivative is 0. So that's what happened on this one that we ended yesterday. Find all the derivatives. Sorry, find all the higher derivatives. We went until it was just going to be 0. At that point, it's trivial. What was this clue that we skipped? When solving for derivatives of trig functions, watch out for... Let's grade homework and see if I can remember what that clue was for. It was supposed to help you on something, some common mistake that you were making or you could make. I don't actually remember what we were watching out for. I think it was simplifying. I think it's simplifying. Oh, sorry, you're in section 2.3, huh? Okay, section 2.3, sorry that took me so long. Let's go ahead and grade our evens. You can just throw your pencil in your notes. We're going to go to section 2.4. I'm going to go find my matryoshkas. Ah, there they are, my matryoshkas. If anybody loves to color, I have a little matryoshka that never got colored. I have his friend too. It was from the graduating class of
27.
This would have been it. Was a senior? That would have been 3 years ago. It was Andrew and her. I guess do I have another student? I don't think so. He was just coming up. But anyway, he colored all of my matryoshkas very prettily, and then he just never got to the last one.
Maybe.
You want to come? I have colored pencils. Anyway, my matryoshkas are for section 2.4. You can be thinking of something inside something, inside something, inside something. That's where we're going today. Although, in math, when do we have things inside of things? What kinds of functions are inside of each other? Compositions of functions? Okay, section 2.3. Number 8. Guys, here's the struggle. You didn't have the answer to try to make it match. So if yours does not look exactly like this, in your colored pen, write it off to the side, and then maybe you have time to compare it right now, and maybe you don't. Maybe you have it right. You just didn't simplify it all the way. So if it's not this exact answer, write it down, and then you can compare. Okay? Write it down first, then you can compare. For instance, a lot of you might have pulled out a 2, and that's not wrong. You might have pulled out a 2, but they didn't. Sometimes multiple choice completely factors, and sometimes it just leaves it. That's number 8. Number 16, the final answer is 8 over 49, but if you got that wrong, come back and check your 8 over x plus 4 quantity square. That should have been your prime. That should have been your prime. You got it? Okay, remember, if you don't have it, write down the right answer, then you can try to make it match. Number 22. Now, you could have done it a different way. You could have used quotient rule. Do you guys see that they just rewrote it?
Yeah.
You could have done quotient rule. Write the final answer. You could have done quotient rule. You just didn't need to. could have actually rewritten him as 1/4 times. You could have taken that guy's derivative. 1/4 would have chilled constant multiple rule, and you would have had 10x minus 0, which would have been 10/4x, which is 5/2. That's another way of rewriting it. Constant multiple. I can leave any multiple, any constant on the outside. But your quotient rule should have gotten the exact same thing, because bottom d top minus top d bottom, derivative of 4 is 0. You shouldn't have had a plus or minus that remained. I should say minus. They rewrote and then they derived. You could have done quotient rule. Both ways work. Could have done quotient rule. Both ways work. Number 54. Whoa! No. Do you guys see that final? Yes, that was my deriving. Watch out for it. I know what goes in the notes now. Did anybody get cosine of 2x? I don't think so. You know what? No. I think you would have gotten cosine squared minus sine squared. How right am I? Did you get product rule? Yeah, product rule. You should have gotten either negative sine squared plus cosine squared, or remember, we could have done the other way. Cosine squared minus sine squared. Are you wrong? No. They wrote it too. But isn't there a trig property that says, oh, I can rewrite it? No. So we might get an answer and need a trig property to make the match? What's forever card 1? Trig properties in unit circle. Wait, every single trig property you ever saw last year?
No.
No. Why? Because AP doesn't necessarily force you to know every single one from last year. They like the double angle ones. To be honest, I've only seen this one. I've only seen this one actually be used on like an AP multiple choice question. Now, once again, I don't see all the released multiple choices. I only see all the released long answers. But the only one I've seen in what they have released is this guy. But does that mean that they'll never do that guy? They could do that guy. Have I ever seen a tangent? That one's going a little bit crazy. I've never seen any of those crazy like A plus B ones or any of those crazy like sum to product ones. I haven't seen a lot of them. But the ones I have seen are the double angle ones, which is why at least that guy's in your forever card. But cosine squared minus sine squared, it's a thing. It's the double angle of cosine. Oh, that's just mean. I know. Number 68. That's why I put it in your forever card. Number 68. Uh-oh. Why aren't you scrolling? Scroll. There we go. Let's get rid of all that ink, though. Boop. Number 68. Final answer is 1. When you plug it in. But the final derivative is no! They did it again! Okay. So check it. Cosine squared minus sine squared is the double angle of cosine, and 1 sine x cosine x plus 1 sine x cosine x is 2 sine x cosine x, which is the double angle of sine. But isn't it nicer to plug into that than it would have been to plug into that? But if you did plug into that, you still well, it's okay though. You should have still gotten 1. It's just there's more room. See, she did it, but there's more room to make mistakes. So check on Abby, make sure she's alive. Number 96. We have the original, and we have the first derivative, and we have the second derivative. Oh, that wasn't bad. Power rules, right? Number 106. Third derivative. They were having too much fun now. Did you guys go to power rules to make your life easy? Did you rewrite it? Or did you quotient for it? And number 112. Did you guys like these ones? Out of the entire homework, get a highlighter. Get a colored pen. Out of the entire homework, these ones are the best ones. She's like, these ones at the end of homework were the best ones. These ones at the end of homework were the best ones, according to the AP, as far as what they actually ask. These ones at the end of homework were the best ones. Did anybody get confused on these nasty ones? Yeah, I had like multiple people ask me about the ones 112 and beyond. What did you guys get? Did I give you 109, 110, 111, and 112? Oh, I didn't give you all of them? Sad times. Can we peek at them real fast? Guys, guys, out of the entire homework? I think it's the most AP-ish. The double angle of sine and the double angle of cosine, that thing is pretty AP-ish. They love doing that. But also 1, 9, 1, 10, 1, 11, and 1, 12. Because they love to not give you functions, but give you enough to solve if only you knew the rules. If only you knew the rules. So top, bottom for quotient rule, it's great. Second D first, it's great. Come on, computer, you can do it. Just open the menu. I'm trying so hard.
Go ahead and pen me.
Okay. Question. According to our derivative rules, how do you take the derivative of some sort of function? Well, I don't know. You didn't tell me what the function is. No, but you do know how to take the derivative. Don't you just find its prime, right? Mm-hmm. Now, I know that's weird. You're like, you're not doing anything. Well, yes, I am. ddx of that is f prime, right? Do we all agree? Yes. But when you get down here and it says, okay, find f prime. Well, guess what? There's stuff on the other side that we have to think about. So how do you find f prime of, well, f prime, the derivative of, is 2 times, well guys, what do we always do? Isn't there a rule when we have a c times some sort of function and we're taking its derivative? It's notation, I know, but it's still important. What happens to the c? It stays. What happens to the function? It gets derived. Oh, so let's use it here. 2 times g would be 2g prime of x. True? Yeah. And what's the derivative of h? Well, h prime of x. Well, I don't know who that is. No, but they gave you clues. So if they want all of this at 2, doesn't that mean let's find f prime of x1 when x equals 2? Yeah. Just plug in 2. But if you plug in 1x, what are you going to do to all of them? Plug in 2 and plug in 2. And if I plug in 2, I get g prime of 2. Oh, that guy, it's negative 2 times 2. And then h prime of 2 is 4. Oh, look at him. But what changed in number 112? 112 is a times. What's the only legal way to do a product?
Oh, that's the answer.
14, yeah, these are the answers from the book. This is my answer. Ignore them. Although we were right. 0. So how does the rule go, guys? F prime of x is going to equal, take this derivative, so second, I rewrite, don't I? D first, now you keep going, plus, who's that? D second, how do I write that? And all I have to do to finish my problem is say, plug in 2. Oh, so f prime of 2 is equal to h of 2 times g prime of 2 plus g of 2 times h prime of 2. And when you go plugging in all of those clues, you can actually solve. H of 2 is negative 1. G prime of 2 is negative 2. G of 2 is 3. And H prime of 2 is 4. There's only one legal use of all those clues. We end up with 12 and 2 is 14, which is exactly what I said it was. Now, here's the dealio. They could do this all sorts of different ways. They could give it to you like that with little like clues that are written out. They could give it to you in some sort of graph and say like, hey, here's G and here's H and here's another graph of like G prime and H prime. And you have to go looking at 2 and at 2 for where are you and where are you and where are you and where are you. They could give it to you in graphs. You could also give it to you not in graphs but in, ooh, we'll get rid of it all. Hold on, let's just try. Don't worry, it's going to be all scribbly and then it's going to disappear if everything goes well. Did I get it all? I think so. They could also give it to you in a table. And in that table, they could say, hey, we have, for these x values, there's g, and there's h, and there's g prime, and there's h prime. And let's tell you all these different x values that you might or might not need. Let's give you, like, I don't know, negative 1, and 0, and 1, and 2. And you would have to go looking at all the 2's and say, who are you at 2? And it would have been 3. And who are you at 2? And it would have been negative 1. And who are you at 2? And it would have been negative 2. And who are you at 2 and 4? They can give you these clues in lots of different ways, but they love to give you expressions where you don't even know the functions. You just have to know the rules. Ugh, that silly AP, and yet these ones are kind of the easiest ones if you know how to do them. P.S. There's one like this on your test. You want to remember. Anyway. Anyway, what else do we have questions on besides 112? Well, besides that whole thing. Were there any more evens during this? Oh, I'm sorry, 116. Oh, I love this one too. This one's good. The AP probably wouldn't ask it because it's so easy. But it wasn't necessarily easy for you last night. I'm just saying the concept is easy once you figure out what's going on. Why did the quadratic, the parabola, have to be the original function if his derivative and second derivative were also on this graph?
Because the derivative of a quadratic is just the
Because the power comes down and you're one less power. What kind of function is one less power than a quadratic? A linear one. And then, what would be the derivative of a linear if you bring down the power of x and the x goes away? Now it's all of a sudden a constant, and a constant looks like that. Oh. So that had to be my original, so that that could be my first derivative, so that that could be my second derivative.
So
all thinking about, who was it? Someone in period 6 came in after school asking about this one. He said, well, this looks kind of like an x squared. I mean, it was shifted. But in his head, he was like, it's an x squared-ish. Oh, 2x would be, 2x would look like that-ish. Then derivative of 2x is 2. Oh, 2 would be that-ish. So he actually made a function in his head and then took the derivatives. That's funny. But maybe you guys have other ways too. Sorry, I just addressed that because I had like 3 people ask me about that one yesterday. All right, anything else you want to see in homework? Odds or evens? Yeah, be quick. 81. Anything else besides 81? Okay, I'm going to go peek at 81. If you guys find something else, just let me know real quick. Otherwise, you can get your notes ready to go as soon as we finish covering. Where is 81? He's up here somewhere. Horizontal tangent line, HTL. Horizontal tangent line has a slope of 0. Right, guys?
Yeah.
Any horizontal line has a slope of 0. So, HTL, slope is 0, and the slope of a tangent line is the derivative. Isn't it?
Yeah.
Horizontal tangent line, his slope is 0, so the slope of the tangent line, the derivative is 0. So all I have to do is divide. Now, Pico, I probably would have made this easier on myself and rewritten it, just, I don't know, a little easier on my brain. But then we have to think of quotient rule. When we think of quotient rule, we end up with G prime is equal to bottom D top minus top D bottom. Derivative of e to the x is himself all over bottom. Ooh, what did I just do? Bottom squared, isn't that a power to a power? So you multiply, but that's super awkward, so we write it like this. Yeah, just so you guys know.
No
You
way.
could technically, I know. You could have technically also just done the little like e to the x squared. Why am I going to take all the time to walk over to my computer, because I can't reach it on the screen, to come up here and make the custom color of my pen green when I usually want it to be white. And then I'm going to come down here and I'm going to hit OK. I'm going to underline that guy and underline this guy. What am I asking you to find?
Something that can be.
Something that's in common. What's in common? Yeah, and we could take out an 8 if you really want to, but let's just do e to the x for now. If I do e to the x, I'm going to have 8 minus, e to the x is gone. Doesn't the minus have to distribute?
Yeah.
So minus 8x plus 16 all over e to the x squared. You could be super snazzy and reduce, since we factored him out of everything. Reduce and e to the x, that's legal. No kittens were killed in the making of that. It is simplifying it. 8 minus 16 would be, plus 16.
8 plus 16.
Would be 24.
Yeah.
I'm saying it's equal to 0, aren't I?
Yeah.
So what's going to happen to any denominator when I'm setting equal to 0? What's the first step I would always do? Multiply. And when I multiply, don't I just get the numerator equals 0? 0 times anything is just 0, right? We could pull out an 8, or we could just subtract the 24 and divide the negative 8. I think we end up with 3. Yeah, the nice thing about e to the x is he is his own derivative, so he'll always be able to factor out. And technically, Zico, up here, before we simplify, whenever we have factors equal to 0, we technically should have set each one equal to 0. He's actually a 0 over 0, so he's like a whole, but he's also a vertical asymptote, so it's kind of weird. But in this one, something for you guys to always keep in mind, and you might want to highlight this too. Highlight as in like forever, highlight as in, hey, this is kind of important to know. This is impossible. E to the x can never be 0, and there are multiple times during the year that you're going to get confused. E to the x can never equal 0. Think about it, if you were to take ln of both sides, that would be dne, because ln of 0 doesn't exist. You can think about it because ln can never hit 0, it has a vertical asymptote there, but it also makes sense that e will never equal 0 because there's a horizontal asymptote there. Anyway, it's impossible for e to ever be 0, so we can always ignore it and say, well, forget you. That's not helpful. With that, if you have any additional homework questions, let me know later, because I at least want us to, oh, sorry, the quick deriving clue at the very end of section 2.3 that you might want to remind yourself about, is simplifying with trig properties. Like we just saw, let's do green because it's review and it's not even calculus. Sine of 2x. Look to your forever card. Sometimes you have something that's right, and it just looks way different than what they have. It might be that they used a property to plug in. There are others, but for right now, we'll just put those two. Those are the ones that showed up in homework. When solving for derivatives of trig functions, watch out for simplifying. It can make the answer look way different than you have. It's not that you're necessarily wrong. It might have just been a rewrite. It might have just been a rewrite trick. What's this? Oh, that's what that is. What's this? Oh, that's the party problem. We don't have time for the party problem today. What's this? Nope, 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 nope. That's a good... Aha! Ready?
Oh no. I was worried about the shape.
Ah! Come on, it's not that bad. Yeah, it kind of is, but it's not horrible. It's not horrible. We're not going to get the exact rule written down. We're not going to get the exact forever card written down. But we are going to get the idea. You don't have to actually draw little matryoshkas.
That's confusing.
Oh, look, but that one has so many. If you ever go to Russia, give me a bigger matryoshka. Then I can have an F of a G and an H of it.
What? Oh,
J of a K of it. I mean, I do have an F and a G and an H, and those are like the most common ones, but every now and then you get a matryoshka.
I'll put mine in. My parents are missionaries to Russia.
See, I think this one should have a so cute. It's healed. Okay. Matryoshkas. Why am I doing matryoshkas? Because there's a function and a function and a function and a function. There's a function and a function and a function and a function. Not always all that many, but sometimes. Not always all that many, but sometimes. And we did see this really snazzy thing last year called decomposing functions.
I like that.
Decomposing functions. The chain rule is for compositions of functions. And it's going to be very, 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 very helpful if we can decompose functions. If we can look at a function and say, hey, there's an outside and there's an inside, and maybe even the inside has another inside. Now, if we look at these right here, I'm just going to, with my blue pen, just showing insides. You see them? I'm just showing insides. I'm just showing insides. You can take a picture of these two pages. You can have them ready for tomorrow, because there's not a lot of calculus on these pages. I see you ready for the 3 count. Before I can really teach you chain rule, I need to teach you how to look at compositions of functions as outsides and insides. All right, cool kids. I'll see you tomorrow. Chain rule. if you want to, you can go find a Khan Academy video just to be ready. Like, what is the shingle? What are we doing? But you can also catch up in other classes tonight because I would not start homework yet.
I'm sorry.
Catch up, catch up. Write down your new forever cards. Later, Gators.
Are you ready for this?
Oh.
Come after